Okay, so here we're going to look in more detail about how we classify a function, and sort of the difference between what a function is and what a relation is. Okay, so a relation is just any set of ordered pairs. So when we say ordered pairs, what we mean is we're basically talking about coordinates, right? So let's say I have a coordinate 1 and 5, right? When we talk about ordered pairs are basically just coordinates, right? Um, because why? It's in a pair, and this sort of pair is showing us, it's sort of showing us a relation, right? It's showing that when our x value is equal to 1, our y value is equal to 2. Or when our input is 1, our output is 5. So it's sort of giving us a relation with the input, between the input and the output. Okay, so that's what a relation is. It's just any set of ordered pairs or any set of coordinates. Now, we also know that if we have a coordinates, we can always graph them, right? So a relation always has a graph. How do we graph coordinates? We graph it on our Cartesian plane, right? Where we have x on this horizontal axis here. Just draw that up. And then y on the vertical axis here. Okay, so 1 and 5 could be, for example, somewhere here. Okay, and the more, this is just a point right now, but the more coordinates you have, the more sort of graphs you can, I guess, draw. Sorry, the more points you have, the more realistic or accurate looking graph you can actually get. Okay, and as we've discussed in previous videos, every relation also has a domain and a range. Okay, so domain is basically where across the horizontal axis our graph lies or our coordinates lie, and the range is where across the y-axis our coordinates lie. Okay, it has x and y coordinates as we mentioned before. Now, in terms of classifying them, we've got 4 types of relations in total. Okay, so there's 4 types of relations in total, and a function is a special type of relation. Okay, so not every function is a relation. Sorry, not every relation is a function. It's kind of like the square and rectangle dilemma, right? That every square is a rectangle, but not every rectangle is a square. Okay, so that is sort of similar thing with functions and with relations here. Okay, so we'll have a look at the 4 different types. The first type of relation is you have a one-to-one relation. Okay, now when we're talking about these relations, we're sort of just referring to how our x and y coordinates are related. Okay, so in a one-to-one relation, every x value corresponds to only one y value. So it corresponds to one y value and one y value only. And then on the other hand, every y value also corresponds to one x value and one x value only. Okay, so for each input, there is only one output, and every output is corresponding to only one input. Okay, so basically what that means is that this is an example of a graph, which is a one-to-one relation, because for every x value, say if I pick this number here, if I go anywhere across the graph, it's only going to intersect the graph at one point. Okay, not more than one point. Okay, same thing if you look across the y-axis. Say if I pick this point here, it's this point, or this line, the y-axis, it's only going to intersect the graph at, again, one point, and not more than one point. So that's what a one-to-one relation sort of means. Okay? When we look at a many-to-one relation, we can have many x values, or we can have more than one x value that correspond to a singular y value. Okay? However, a singular x value cannot correspond to multiple y values. So what do we mean by that? If we look here, we can see that this one at this value of -5, that corresponds to A. However, here we have two x values. Right? We have the values 0 and 5. They are both corresponding to a y value of 9. Okay? So if you look at this graph here, this is a parabola, and this is an example of a many-to-one relation. Right? It's a quadratic equation. So if you look here, we can see that for this y value, just say if you pick this y value here, and if you draw a line through it, there's two x points that are giving the same y value. And why do we think that's the case in quadratics or in a parabola like this? That's because remember when we square a number, if we square, say, -5, you will get 25. If we square +5, we'll also get 25. Right, so say, for example, if this line over here is 9, then these two values could be -3, because -3 squared is 3, and +3. If +3 squared is also 9. Okay? So that's an example where you can have many x values that just give us a singular y value. But if you look at the y values, if we look at the x values, each x value is only given us one y value. So it's not like you can put in the number 3 in a quadratic. You can't get two different answers. Okay? In any, if you put in y is equal to 3 squared, you're only going to get one answer. We're never going to get two answers. Okay? Now, here's a one-to-many relation. So over here, a singular x value corresponds to multiple y values. Okay? So here, if you look at the relation diagram here, we've got the number 1, so we've got the input 1, and that's actually given us two different values here. Right? It's giving us the number 1 and the number 5. Okay? So if we look at this graph, for example, if we look at the number 6, right, it's giving us a value of about 8, and it's also giving us a value of our -8 here. So each x value, or one x value, is giving us multiple y values. However, each y value is only corresponding to one x value. So that means that if we look at each y value here, it's only giving us a maximum one x value. So for example, 3, it's only corresponding to this x value here. The number -3 is only corresponding to this x value. We're not getting more than one x value. And the last one relation that we have is a many-to-many relationship. And this is when each x value corresponds to multiple y values, and each y value can also correspond to multiple x values. So if we look at that on the diagram here, we've got the input 0 here, and that's corresponding to the y values of 1 and 4. Then we've also got a y value of, say, -2, which is corresponding to inputs of -3 and 2. Okay, so a single x value can give many y values, and more than one x value can give a single y value as well. Now, the most popular example of this sort of relation is a circle, right? If we've got a circle graph, we can see that if we pick an x value, let's say we pick this x value here, we're getting true y values, right? We're getting one y value here, and we're getting a y value here. Similarly, if we pick a y value, okay, we're getting two x values. We're getting an x value here, and we're getting an x value here. Okay, so those are the 4 different types of relations. Now, how do we classify which of these 4 relations are functions? Okay, so only 2 of these relations classify as functions. And those are the one-to-one relation and the many-to-one relation. And to do a simple test of that, we use the vertical line test. Okay, so what the vertical line test shows us is basically a relation can only be a function if it gives us a single y input for every x input. So basically every input that we have, that we put in, it can only give us a maximum of one output, right? So in these two relations, we have one x value gives us one y value. Okay, so that is a function. This is also a function. Many-to-one is also a function because, yes, we can have multiple x values that are giving us the same y value, but each x value is only giving one y value, right? It's not giving more than one y value. So that means still every input is still associated with only one output. So that is also a function. Now we can use a vertical line test, which we're going to go through on these examples. And that's basically what that basically means is that we draw a vertical line throughout the entire function. And if at any point of the graph, we get two sort of intersections, then it's not a function. Okay, so what do I mean by that? Let's have a look at this question here. So what the vertical line test means is that I'm going to draw vertical lines. Sorry, just give me one moment. if at any point in this time, if at any point in this graph, I draw a vertical line, so over here, or over here, or over here, or over here, anywhere, it cannot intersect the graph at more than one spot. So if I look at here, yep, it's intersecting the graph at only one spot. So is it a function? Well, the answer is no, because if you look here, it's intersecting the graph at more than one point. So that is not a function. Okay, this one is also not a function. If we intersect the graph here, we can see that it's intersecting at more than one point. So it's not a function. This one is not a function. This one is also not a function. This one is a function, right? At any point of the graph, we're intersecting at a maximum of one spot. So this is a function. This is a function. And this is also not a function. Okay?